Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue what we started in a previous video. It's about the acid and bases. Today we're going to focus on pH and pOH, as well as some equations that are used in order to solve some problems in the exams, whether they are the ministry exams or EmSat or AP classroom. So let's get started. As I told you, today we're going to focus on the pH and pOH, as well as the strong acids and strong bases. What do you mean by pH? A pH is a measure of acidity. So basically, it measures how strong or weak the acids are. For example, we have something called the pH scale, and it starts from 0 to 14. As you can see, for example, at 7, the solution is neutral, just like water. And we studied previously that in water, the concentration of H positive equals to the concentration of OH negative. And both of them, they equal to 1 times 10 to the power of negative 7 at molar, at 25 Celsius. I recommend you guys recall or watch that video again before we proceed. So, for example, if you look at the tomato here, you will find that it has a pH of 4. Excuse me. That means it's acidic because all the solutions that have pH lower than 7 is going to be acidic. And all the solutions have pH greater than 7, they're going to be alkaline or basic. So if you take a look at the ammonia solution, of course it's basic because its pH is 11. Stomach tablet, for example, also it's basic because the pH is 10. Whereas the lemon has pH of 2, and that's why the lemon is acidic, as well as the battery, the stomach acid, etc. Let's now check some equations that are very important, how to calculate the pH and the pOH. pH, it equals to the negative logarithm of the concentration of hydrogen ions in the solution. And I'm going to write the equation for pOH, which also equals to negative log the concentration of OH negative in the solution. Now, when the solution is neutral, as you see here, the pH should be 7. So whenever we have a pH of 7, the solution is neutral. It's not acidic, it's not basic. And the concentration of H positive equals to the concentration of OH negative. That means the concentration of H positive equals to 1 times 10 to the power of negative 7. When the solution is acidic, that means the concentration of H positive is greater than the concentration of OH negative, which means the concentration of H positive is greater than 1 times 10 to the power of negative 7. And therefore the pH, if you calculate it, for example, in this case, let's take pH equals to negative log 1 times 10 to the power of negative 8. No, we're talking here about greater than. Okay, so 1 times 10 to the power of, let's say, negative 5. That means the pH, if you calculate it, it equals to 5, which is less than 7, and that's make it acidic solution. If the concentration of H positive is less than the concentration of OH negative, that means H positive is less than 1 times 10 to the power of negative 7. Therefore, the solution will be basic. And if we take an example, pH equals to negative log 1 times 10 to the power of any number less than to the power of negative 7. So it's going to be negative 8, let's say. That means pH equals to 8, which is greater than 7. So the solution in this case will be basic. Now, let's recall some equations that Kw equals to the concentration of H positive multiplied by the concentration of OH negative. We studied that previously. And at 25 Celsius, this equals to 1 times 10 to the power of negative 14. All right, let's have an example problem. The concentration of H positive ions in a solution was 3.2 times 10 to the power of negative 4 molar. Only half of the solution was consumed. The other half, after it had been standing open to the air for a month, was found to have a hydrogen ion concentration equals to 1 times 10 to the power of negative 3 molar. Calculate the pH of the solution on these two occasions. So let's start with the first occasion. Number 1, the concentration of H positive was equal to 3.2 times 10 to the power of negative 4 molar. That means the pH equals to negative log the concentration of H positive, and which equals to negative log 3.2 times 10 to the power of negative 4. Mathematics, using calculator, you're going to find it. For the second one, the same thing. We found that the pH now, the concentration of hydrogen ions now, it equals to 1 times 10 to the power of negative 3 molar. And that means also the pH equals to negative log 1 times 10 to the power of negative 3. Using calculators again, you can solve it. So this is the first example about the pH. The other example now is when you have the pH and you are asked to do the to find the concentration of the ions. The pH of rainwater collected in a certain region on a particular day was 4.82. So this is the pH now you are given. And what they are asking you is to calculate the concentration of H positive in the rainwater. We know that pH equals to negative log the concentration of H positive. Therefore, we need to do the antilog. That means the H positive should equal to 10 to the power of negative pH. This is how we solve it for the concentration of H positive. Now, which equals to 10 to the power of negative 4.82. Using calculator, you will find the pH. What if in this question also ask you, let's make it a little harder. If they ask you how much is the concentration of OH negative in this case? Also. So we need to do something. We need to do a trick here. Because we have the pH. And if you remember, the Kw equals to the concentration of H positive multiplied by the concentration of OH negative. We have the Kw. We have the H positive. We already found it here in the first unknown. Simply we can find the OH negative. Also, I'm going to add the last problem, or the last equation, I mean, that we need to use. pH plus pOH always equals to 14. So in the problems, when you have, for example, pH, and they are asking you about the pOH, you can find it directly from this equation. Okay, last question. In an NaOH solution, OH negative is 2.9 times 10 to the power of negative 4 molar. Calculate the pH. You have the concentration of pOH. Now, from the concentration of OH, we can find the pOH, which equals to negative log the concentration of OH negative, which is 2.9 times 10 to the power of negative 4. Now you found the pOH. pH equals to 14 minus pOH. It's very simple. Those questions usually they come as multiple choice questions, so we need to practice more and we need to be fast about solving those problems. Now, the last section of this lesson, of this video, is going to be about the strong acids and strong bases. Look here. We have strong acids, just like HClO4, HI, HNO3, HCl, HBr, H2SO4, all of them are strong acids. And also we have weak acids, HCOOH, HNO2, CH3COOH, HCN, and HF. As well as, I'm going to add this to H2SO3. Similarly, we have strong bases and we have weak bases. We need to know the strong acids from the strong base, from the weak acids, and the strong bases from the weak bases. All right. What is the difference between strong acid and strong base? Strong acid and weak acid. Look here. For example, if we have the acid HA, and when you put it in water, if HA is a strong acid, it will dissociate completely. It will decompose completely into the ions. So it will give you H positive plus A negative. And that means the concentration of HA before the solvation or before dissolving in water, it equals to the concentration of H positive in this case. But if HA is a weak acid, so the dissociation is not going to be 100%. So here we have it 100% dissociation. It will give you the ions. And the concentration, because 1 mole gives you 1 mole, so the concentration of HA, the original acid, it equals to the concentration of H positive. Now, if HA is a weak acid, as you can see here, this is the weak acid. We still have acid. After you put it in water, we still have acid. Not all of them, they dissolve in water, or it will not give you 100% dissociation. So HA will give you H positive plus A negative. Look here, it's not 100%, it's a reversible reaction. And in this case, HA, the concentration, the initial concentration of the acid, it doesn't equal to the concentration of H positive. We're going to use this idea to solve problems in next video. But today, let's focus on solving some problems about the strong acids. Let's have this problem. Calculate the pH of the following solutions. A, 1 times 10 to the power of negative 3 HCl. We need, as I told you, to memorize the strong acids. HCl, HBr, HI are strong acids, whereas HF is a weak acid. So HCl is considered as a strong acid. So let's do it. We're going to write the equation. HCl completely dissociate to one arrow. It's not reversible reaction, and it will give you H positive plus Cl negative. Now, the concentration of HCl before it equals to the concentration of H positive after the dissociation. As you can see here, the concentration of HCl, which is a strong acid, equals to the concentration of H positive. Therefore, we have now the concentration of H positive, and we need the pH. That means the pH equals to negative log the concentration of H positive, which equals to negative log 1 times 10 to the power of negative 3. Which equals to 3. And as you can see, 3, it's a very strong acid. In B, now, we have here, also we need to calculate the pH, but we have a base, and BaOH2 is a very strong base. What can we do in this case? We have the concentration of BaOH2. I'm going to write the equation. And it dissociates completely to give you Ba positive 2 plus OH negative 1, but 2 of it, so I'm going to write number 2 here. So if this was, the concentration is X, so this one is 2X. All right, now, here in this case, we have the concentration is 0.02. That means the concentration of OH negative, we need to multiply it by 2, so it equals to 0.04 molar. Now, pOH equals to negative log the concentration of OH negative, which is 0.04. And you find the answer using the calculator. But this is the pOH. We're asked to solve for pH. That means pH equals to 14 minus the pOH that you got. And finish. It's very simple. Let's check the last example for today. Calculate the pH of 0.036 molar nitrous acid HNO2 solution. All right, let's follow the same case. But if we check the weak acids, we will find that the nitrous acid HNO2 is a weak acid. So the concentration of the acid does not equal the concentration of H positive. Because HNO2 does not completely dissociate in water to give you the H positive plus NO2 negative. And this problem, we're going to solve it when we study how we find the pH and the pOH for the weak acids and weak bases. What do we need to take from this lesson? The pH equations, the pH scale, the pOH and pH relationship. We solved some example problem you need to practice on. We need to memorize those acids and bases, the weak acids and weak bases, also the strong acids and strong bases, and how to calculate the pH and pOH for strong acids and strong bases. I hope you guys learned something new today. I'm going to see you next video, and the next video we're going to focus on the weak acids and weak bases, and we're going to solve similar problems. Have a nice day. Bye-bye.